Today's lesson is going to be on something called the line of symmetry. And you guys might be familiar with what symmetry is. If so, awesome. We're going to go over kind of what it is and how we can see it in these three shapes, A, B, and C. So if we start by looking at shape A, if we want to find the line of symmetry, that means we want to find a place where we can draw a line somewhere through the shape where that line will cut the shape directly in half to where as if we folded the shape, it would match up with itself. Okay, so I want you guys to think about these three shapes and see if you could think of where you would draw a line, or maybe more than one line, to create a line of symmetry. So if we look at shape A, if we want to fold this directly in half so that it folds on itself, I know we can put a line right here, and that's going to make, if we fold this side over here on top of that line, it's going to line up right there. My line is not perfect, but you get the idea. And then the same here. We could draw a line through the middle here, which would create that same effect, where if we folded it this way, it would then line up with itself. So this shape has two lines of symmetry. And then we come over to shape B. So shape B, we could draw a line through this vertice, and we could get a line of symmetry folded this way. We could get one here and one here. So shape B has three lines of symmetry. So another way that we can think of these lines of symmetry is reflection symmetry. And that is where it's the same idea of folding it over, but thinking about it reflecting it onto itself. So if we were to reflect this shape, and if you think of looking in a mirror, how it mirrors the image or it flips the image, if we were to reflect the shape over this line, then we would be able to see that it would match up with itself. Okay, now let's look at shape C. Is there anywhere that we can draw a line to where if we were to fold it along that line, the shape would match up? If we were to draw a line, let's say down the middle of the shape here, if we envision folding this in half, it is not going to match up over on this side. And same if we were to draw a line down the middle here. So shape C has no lines of reflection. There's none of them.
All right, now we're going to talk about reflecting shapes over a line of symmetry. So here we have this kind of funky looking shape, and we got our line of symmetry, and we want to see what is going to be the resulting image. So this is what we call a preimage. We reflect it, that is called our image. All right, so one thing you can do at home, if you have like a piece of paper, ours is kind of transparent so you can see it better, but you can take the shape and you can trace it. You've traced it, and then when you take it and you have copied it over, you can reflect it and reline up your shape, and then you can kind of roughly get an idea of where your image is going to land. So that is a technique you can use if you're having a hard time visualizing where is my image going to end up. So again, you trace it and line it up with the line of reflection again. So that kind of helps you visualize what's going on. All right, thank you, Emma. Okay, so you can see here from this part of our preimage and where it corresponds to on the actual image, you can see that this is like 1 unit apart here, and it's also 1 unit apart here. So you can also use that to help you in your drawing method. So this point here is 1 unit away, so I know it's going to be 1 unit away over here. Then this point is 1, 2, 3 units away, and so this is also going to be 1, 2, 3 units away over there. All right. This is 2 units up. This is 2 units up. So roughly here. So far we've got this comes down here and it lines up here. Then this pokes out this way. So I'm also going to poke this out this way. And then we go up and over and up and over. And then it looks like it cuts diagonally. So we're going to cut diagonally as well. And then we come back down. All right, now you have a resulting image. Woohoo!
All right, so now we're going to try reflecting this shape when the line of reflection is diagonal. This is a little bit trickier because it's harder to see the distance that each point is from the line of reflection. So if we look at this point right here, we can see that it is some distance from the line of reflection. It goes diagonally through this part of the grid. And so to match it up on the other side of the line of reflection, it has to be the same. So we have to then extend this line the same distance and put a point here. Another way we can think about it is kind of the idea of our slope triangle. If we want to figure out how far up or down, how far over I have to go from my point to get to the line of reflection. So I have to go down 1 over 1. So that means that I will be the same distance over here, down 1 over 1. You can think about it either way. So then if we come up to this point, it's going to be the same thing because it's 1 box diagonally away, so it's going to be the same distance over here. Or we can think of it with our slope triangle. It's got to be the same. Okay, now let's look at maybe this point up here. It's a little bit further away, so let's think about how we could see this. So we can draw a line through the grid to the line of reflection, and we see that we had to go through 1, 2, 3 boxes. So we're going to do the same thing over here. 1, 2, 3 boxes, and we're going to end up with a point right here. Again, we could use the slope idea, and we could see we go from this point, we go down 1, 2, 3, and then we go over 1, 2, 3. We'll do the same thing from here. 1, 2, 3, and then over 1, 2, 3, and we match it up there. So there's a couple different ways you can think about it, but our goal is to make sure that each point from our pre-image right here is the same distance away from the line of reflection as each point in our image. All right, so as you can see, as we reflected this shape over this diagonal line, it's like we took it and we flipped it over here. So if we were to take a piece of paper and lay it on this line, we can fold it in half on that line and these shapes would line up. And so the key with reflections is that we have to make sure that each point from our pre-image is the same distance to the line of reflection as the points in our image. And the shapes should be congruent, which means the shape should be the same.
All right, now we're going to more formally define and recognize whether something is a reflection or not. So let's check out this example here with the lightning bolt. We got the original image or the pre-image, and then we have its image. So is this a reflection? Yes or no? Looking at it, it definitely does look like a reflection. It's flipped. And just like Emma was telling us earlier, if I take one point of this corner of the lightning bolt, and it should be the same distance as it is from the line of reflection to the other side. So this should be the same distance, right? That's the exact same distance if I do it with any point, right? Any point on the lightning bolt, if I go over here, this is the same across as it is here. Okay, so yes, this would be a reflection. All right, let's check out this next one here with this heart. Again, we can use that trick that Emma was showing us where we pick a point and see is this the same distance across as it is on this side? Looks like that is. How about the bottom of the heart? And it looks like the image looks like the same distance away, and the image is flipped, right? The image is flipped here and here. So this definitely looks like a reflection. Okay, something else to notice as well is each of my lines here going across, they are parallel with each other, right? They are parallel with each other, and they're also perpendicular or form a 90-degree angle with the line of symmetry. Every equidistant line is perpendicular with the line of symmetry. Same thing here. We got nice perpendicular stuff happening here. Again, these are not perfect, but yes, that's 90 degrees, and that is also 90 degrees. Okay, all right, let's check out this next one here. Looks like we got this girl, and bloop. It does not look like a reflection, right? We would expect her hand, if it was here, if it's that far apart, then her hand should be that far apart here, and it's not, right? It should be inverted, right? Her face should be facing the opposite direction. So we know that is not a reflection, and we'll talk more about what kind of transformation this is in the next video. All right, let's check out this one here. If I connect it to its image over here, do we see how this line is not perpendicular with the line of reflection? None of these are parallel, right? These are all nice and parallel and perpendicular with the line of reflection, while these are not parallel with each other, and they're also not perpendicular with the line of reflection. Awesome.